All right, we're going to talk about identifying functions. So how do I know something is a function? And so we're going to go through some examples to help understand how to do this. First example, which of the relations has a domain of -5, 0, and 5. Now, on this one, so anything that is put together and said that they are connected is considered a relation. And then domain is going to relate to x values. So anytime I'm looking for the relation that has a domain of this, we're looking for anything that the x values are going to be -5, 0, and 5. So for example, in this one, I could have a relation that looks like an XY chart, and it doesn't matter what these were, but if I saw that the X values were this -5, 0, and 5, then I would say this relation has a domain of -5, 0, and 5. Next example. Is this a function? And they give us a relation to look at. Okay, so how do I tell if a relation actually is a function? That means that for every x, there's only one y answer. So that means that I can't have two different y numbers related to one x number. So in this case, it's not labeled as such, but the left side is going to be our x's, and the y side is going to be our y's, the right side, and which means our input, output, or x or y. So in this case, we're going to follow the arrows. So our input values, our x values are 1, 3, and 5. We want to make sure that by looking at the arrows that not one x number has multiple y numbers. So the 1 only has one arrow, it relates to 2. The 3 only has one number, it relates to 6, and 5 only has one number, it relates to 4. So since each x only has one y value, then this would be a function. We would say, yes, it is. Next example, is this a function? So we're given some points. Again, a relation. Okay, so just like in the last one, even though this one looks a little different, these are ordered pairs. And remember, ordered pairs are x and y. And so to determine if it's a function, we're looking at the x's to make sure they have only one y output. So our x's are here, of each one. And so basically we're looking for any duplicates. So here we have 1, it had the 3 output. We have -1, it had a 4 output. We have a 1, it had a 4 output. And we have a 2, and it had a 3 output. Notice that's the same X. So basically they're saying they plugged in 1 and got out 3, and then they plugged 1 in again and got out 4. Which, saying it that way goes, well, that doesn't make any sense. Well, that's the idea. Is it actually functioning? And the answer is no, this is not a function because we plugged in the same X and got 2 different Y values. All right, next example. Is this a function? Okay, so this time they drew it. Remember that if we have X's and Y's coordinates, then we can graph them. So if we have the graph, we don't want to try to figure out all the points that are on there, but we want to be able to determine if this is a function or not. So remember, the idea is that I have one X has only one Y value. Okay? So if I were to pick any points anywhere, that's kind of where I'm looking. Do I have just one Y value, right? Would it be 1 point? However, we have a cool test called the vertical line test. Vertical means up and down. So the vertical line test says if I can draw a vertical line anywhere, so if I were to draw a line like this, and I would only touch it in one spot, and again, it has to happen everywhere. So far I'm like, so far so good. However, let's look in the middle. So if I were to draw this line, what happens? I hit multiple spots. So whatever that X value is, it got 3 different Y values. So what does that mean? Not a function. Okay? So the vertical line test is very helpful with graphs. I just look to see, can I draw a vertical line anywhere and only touch the graph in one spot and one spot only. That's it. As you work through your lesson, if you have any questions, make sure to ask your teacher. Have a great day.